As the Rosetta orbiter continues its science mission, the lander's future is less certain. Although Philae recently sent signals from the comet, it's unknown if there will be any more science ahead for its 10 instruments. This camera is exactly the same as one of them, the ROsetta Lander Imaging System, or ROLIS. Located beneath the lander, it took the descent images to the comet in November, and now has a bird's-eye view of the comet's surface.
So what we saw with ROLIS is that we have a surface which is covered with gravel. We thought we would see a lot of fine dust, but we didn't see any. So it was a surprise to us. And this will help us understanding what mechanisms are at work on the comet. And now we will have to figure out where these pebbles that are on the surface come from.
The ROLIS copy is at the German Space Agency in Berlin. It's located in this clean room, where operations engineer Ivanka Pelivan generates and tests the telecommands that are sent to the orbiter and then relayed to the camera on board the lander on the comet. An array of 4 types of monochromatic light illuminates the surface: blue, green, red, and infrared, which is invisible. Each light is a different wavelength and provides different spectral information about the surface. The lens opens to produce very sharp pictures in the near field, about 30 centimetres away. With the lens on, we get clear images further away. If Philae ever does fully wake up, telecommands can be sent to ROLIS to work under multiple conditions.
So it will continue working on characterizing the surface of the comet. There's the plan to rotate the lander, and then we will gain more information of the neighboring parts of the surface. And yeah, so the plan is to have a ROLIS image every time the lander does a rotation.
Data from all Philae's instruments has informed the work of the other scientific teams. Rosetta scientists have analysed grains from the comet and discovered that it contains carbon-rich molecules from the early formation of our solar system.
These grains are really the complex molecule that has been then put in the planetary oceans and probably played a critical role for the emergence of life.
The lander's unexpected bounces on landing caused some teams a few headaches. Close-up images from ROLIS showed the lander was probably tilted upwards, which explains why a fully extended drill couldn't deliver a soil sample to the COSAC instrument. Fortunately, COSAC worked perfectly and could analyse dust samples as planned. At the Max Planck Institute for Solar System Research in Germany, there's a flight replica of the COSAC instrument inside this vacuum chamber. COSAC has already detected over a dozen molecules containing carbon, hydrogen, nitrogen and oxygen from the dust cloud kicked up from landing.
The sample would have been great. Then again, the whole sequence worked. I mean, after 10 years in flight, the whole instrument behaved as it should have done. So everything which was under our influence, what we built, what we did, what we planned, programmed, tested, did work, just that the comet wasn't quite as cooperative as we would have hoped.
The mission team will continue trying to obtain science from the lander as the orbiter makes new observations of the comet. Now the Rosetta mission has been extended by 9 months until September 2016, the orbiter can also witness the comet's declining activity as it moves away from the Sun after perihelion in August. This will give an even greater understanding of how comets evolve during their lifetime.